Hi everybody. In this video, I want to talk specifically now about a little bit of algebra, start getting into it, and look at algebraic expressions. So first of all, let's talk a little bit about some definitions here. And the first one is going to be a variable. So a variable is just a letter or a symbol used to represent an unknown number. Okay. So typically we tend to use English letters, right, because we are speaking in English, but you can use other letters too. Oftentimes they use Greek letters as well instead. So that's why I kind of put symbol there, but typically it's going to be a letter to represent an unknown number. Okay. And an algebraic expression is just a combination of operations. So again, then it could be adding, subtracting, dividing, or multiplying. On variables and numbers. Sometimes we'll just use the word expression instead and we'll drop algebraic. So if you just hear the word expression, that's totally fine. One thing you do want to note though is that there is no really equal sign in an expression. We're not solving here to get like an equation. We'll see that in a little bit. But it's really just a combination of operations on variables and numbers. And these can also include grouping symbols. Exponents are fine too. But no equal signs really, unless you're plugging in and solving some values. Okay. So for example, something like 4 plus x. Another example could be 7x. Another example could be something like, let's see, 4z minus 5y plus 6. Now, one thing I'll note is that when there is no symbol, between a number and a variable, this implies multiplication. So if you see 7x, this really means 7 times x. If you see 4z, 4 times z, or 5 times y. We're going to drop that multiplication symbol. So you'll see it in your text a little bit here and there, but really as we get more into algebra, we drop that multiplication symbol. So in general, for multiplying, if you see two things touching, right, two parentheses touching, a number and a variable touching, two variables touching, then you have some sort of multiplication going on there. Okay, so these are just some examples. Let's look at a couple more examples. So I just mentioned variables touching, right? Something like this, 7xy minus 6x is also an expression. So you can multiply variables together. We can bring in things like grouping symbols. So 7 times x plus y. Bring in the distributive property in a little bit. We can bring in exponents here. I don't know why I keep using 7. Let's do something different. How about 5x squared? Or maybe 10x squared plus 5xy minus 7y squared. Okay, so combinations with exponents, adding, subtracting, multiplying, dividing. I don't really have a lot of dividing here. I guess I can bring a dividing problem in. maybe 1/2 x, something like that, right? I have division there with that fraction. Or maybe something like x plus y over 2, right? So we can bring in division there as well. So any of these are all just examples of expressions. Now, one thing we really like to do with expressions is we like to evaluate expressions. Now, this means what you're going to do is you're going to plug a number in for the variable or variables and simplify. So you're going to get like one number answer out. So for example, let's evaluate 2x plus 3y, or x equals 1 and y equals 4. So what we're going to do is we're going to take those numbers and plug them in for the variables instead. Now, what I usually like to do is I like to use parentheses here. So where I see an x, I'm going to replace it with the number 1. So this becomes 2. And then again, that x, I'm going to replace with number 1. And then for my y, I'm going to do the same thing. Wherever I see that y, I'm going to replace it with, in this case, the number 4. I like to use parentheses when I evaluate because it reminds me what to do. So here I can see 2x means 2 times x. So I'm reminded here this is 2 times 1. I'm multiplying. And you do need to use your order of operations when simplifying. 2 times 1 is 2. 3 times 4 is 12. So I have 14 here for my answer. Now I am using equal signs to help me simplify, but notice that the original expression does not have an equal sign. So I'm just trying to clarify the difference between an equation. Let's evaluate x plus 5y over 10. And let's use x equals 40 and y equals 20. So I'm going to just replace my values. So when I see my x, I'm going to replace it with 40. Now, you don't have to really use parentheses here. It's not going to make a difference, although I like to be in that habit, so I'm going to go ahead and do it anyway. And then when I replace my y, I'm going to replace it with 20. Now I am going to simplify using my order of operations. So here I just have a 40, and here I'm going to do my multiplication first. 5 times 20 is 100. 40 plus 100 is 140. And then you can go ahead and do your division out if you need to longhand, but just remember that we can also divide by 10 very easily. So for each 0 here in the 10 factor, you cancel a 0 up top. So this becomes like this, 1 0 at a time, and then I have 14 divided by 1, which is just 14. And let me just do one more example here. All right, let's evaluate 2x squared plus y, or x equals 3, and y equals 5. So I'm going to go ahead and wherever I see that x, I'm going to go ahead and plug in a 3 there. So just be careful. I have a 2, and then I'm plugging in a 3, and I still have a square. And then when I see the y, I'm going to replace that with 5. Notice that I'm really staying lined up, which is important. And now I'm going to simplify. So I do have to use my order of operations since exponent is going to get simplified first. So that becomes 2 times 3 squared is 3 times 3, so 9. Yeah, the parentheses not really doing anything, so I'm just going to bring it down. 2 times 9 is 18. And then I have 18 plus 5, so I'm looking at 23. So evaluating is one of those things that we commonly do with our exponents here. So another thing I want to do with expressions, we actually have a lot of expressions too that are formulas. Maybe I should just do one more example there. So let's do an example. So obviously the area of a rectangle is given by length times width. And so we can use the expression L times W there, right? I guess to find the area. So we can evaluate when maybe the length is equal to 4 feet and the width is equal to 6 feet. So length times width, my length is 4, my width is 6, 4 times 6 is 24, and then just don't forget your units get squared too here. So we can also use these in the same technique in formulas as well. And the other application we like to do with expressions too is to translate phrases. So this is kind of the beginning of word problems here. And you want to think back to all of those different techniques that we have used, all of those keywords. So it may be helpful just to kind of quickly list some of them, because I know we've already done them in other sections. So keywords we saw for adding were things like sum, plus, obviously the word add, more than, increased, by, total. So those are some words that we saw there. For subtraction, things like difference, minus, obviously subtract, less than or less, subtract and subtract from, right? Decreased by. We also talked about here comparing or change, right? Sometimes, even though it's not a key word, the idea of how things change is subtraction too. For multiplication, words like product, times, multiply, of. Now, a couple new ones here. Double would mean times 2. Triple is times 3. Quadruple is times 4, etc. So there are a lot of other specific keywords there that we can start thinking about. And for division, we saw quotient, obviously divide, sharing or grouping equally. The word per, divide or divided by as well, etc. So any sort of equal grouping there. So let's just do a few examples here too. So we are going to write as an algebraic expression. And again, you could just say the word expression there. And we're going to use x here to represent a number. So we're going to use x as our variable in this case, but you can really use any letter you wanted to. A lot of times people use n for number instead. So that tends to be pretty common too, but you'll use x. So 5 increased by 2. Well, that word increase typically means to add. And it does. There's not too much going on. It's pretty straightforward. So we're going to take that number 5 and we're going to increase it by 2. Now, I could also write something like this. 5 increased by a number. So it's the same setup, but here I'm not specifying what the number is. So we're going to use is x for that number. So I have 5 plus x instead. Oops. reversed by. Let's try it again. The product of 2 and 3. Well, product means multiplication. So I'm going to be multiplying here. This would be 2 times 3. But we could take this to the next level, right? The product of 2 and a number. So the number I'm letting here be x. So we're going to do 2 times x, or just 2x. All right, let's do some more examples. How about 5 subtracted from 10? Well, that word subtract means subtraction, of course. But remember that word from we talked about before, how it changes the order? From and than often change the order. So 5 subtracted from 10 is actually 10 minus 5. So something like 5 subtracted from a number, again, I don't know the number here, we're going to let this number be x, is going to be x minus 5. Okay. How about the quotient of a number and 6? Quotient means division, and division is always in order. It's important that you stay in order. So if I say a number and 6, that means the number comes first. And again, I'm using x here for that number. So we're saying x divided by 6. Or we can write it as x divided by 6. We typically don't do it this way. We typically only use that bar for long division. So it would usually be one of these two would be the more common ways to write it. Although this is not wrong, you just don't see it very often. GH. Let's do one more. What if I say triple a number increased by 4? Well, triple a number. Triple means to multiply it by 3, right? So we're doing 3 times a number. And increase by typically means to add. So plus 4. So this just becomes 3x plus. Okay, so just a few examples of how to translate. And again, watch for those keywords. So we mentioned one here. The word from often reverses the order, as does the word than. So if I said less than, that also reverses the order versus just something like less. So watch out for those little things that we've talked about in the last few videos as well.